Hey everybody, this is Larry. This is day 28 of the Leetcode Day Challenge. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about today's farm. We've been doing a lot of diagonals lately, apparently. I don't know what the problem is about. We just see that they're diagonals, right? So let's get to it. Today is a rest day for me, so I am very, feels nice. Took a couple of naps. Yeah. That's it. I don't know. Let's take a look at today's farm. No long thing today. Let's take a look at today's farm with 3446 sort matrix by diagonals. All right, you have a grid, a square grid. Diagonals are bottom left triangle. It's just annoying. It seems like. Including the middle one, are sorted in non-decreasing order. Non-decreasing order. All right. I mean, it just seems like, yeah. I don't know. I mean, what is there to say about this one? I think this one is pretty straightforward, right? It's just about implementation, and you just have to be careful. You probably can do it in place if you implement your own sorter. Maybe you can be a little bit better if. Could be interesting to implement it in place, but you probably have to do a sorting. I'm trying to think whether you could do it through a library in a very clever way. Like in C or C++, you probably can by passing the pointers or the memory addresses more specifically, but I don't know if you could do it in Python easily. But we're just going to mess around, so let's go, right? I know it's a square grid, but I always like writing out this way so that it doesn't confuse me as much. And at least with this one, it doesn't seem like it matters whether it is true or not. And again, for the we talked about this a couple of days ago, so if you were watching that video, I'm trying to bring up the drawing thing. Hang on. If you're watching that video, then you'll know that we kind of talked about it a little bit, right? So we have a grid. It's more square than that. So if you go along this diagonal, what does that mean? Well, it means that, and there were only two diagonals, right? So you just have to check which one it is, because it's either x minus y is equal to k or x plus y is equal to k. And honestly, I don't remember it in the sense that, like, I don't memorize it, but it's also like a 2-second check, right? Which is, okay, you have 0, 0, you have 1, 1, you have 2, 2, so it's this one. That's it. K is equal to 0, right? If you go the other diagonal, then you'll see that in this case it is 0, 0, and then maybe you have, like, 1, 1, 2, 0, 0, 2 or something like that, right? So then you'll be in this case. But in any case, for this one, it is going to be x minus y 0 to k, right? And then we could, I don't know, we could figure out how to do it. I think if I did this during a contest, and I probably did, I'd probably just dump everything in an array and then just sort it that way without thinking about it. If I have to guess, I would, to kind of, like a speed run type thing, which I probably did during the contest, I would write something like right? Then now we have for x in range of R, y in range of C, f of, in this case, it's x minus y, as we said, x, y, something like this, and you sort and then put it back in, in one direction, the other, some if statements, right? Today, maybe I'm going to try to see if I could do a little bit better, in that, okay, here this is literally O of n, because each item in the grid will appear once in this grid, so it's not too bad. And you can prove that this is n log n. Sorry, when I say n, I don't mean the input row n, I mean like the number of elements, right? Though you could also say but yeah, summation is going to be n log n, because you can imagine that the worst case is just sorting every element, and that's going to be n log n, where n is the number of elements, or r times c, right? So you could certainly do that. Maybe check the I mean, yes, 10 by 10. I don't even know why I'm debating it, right? But those are the things you can do. You can also try to do them in row order or diagonal order, I suppose. Right? Maybe you could do like yeah, for k in range. How would you go? Maybe that is something for me to practice then, right? So let's do it. So maybe I would say for diagonal order, let's go D. You wouldn't. It doesn't start at 0 because 0 is the middle diagonal, right? So what's the well, the worst one would be the one on upper right, because then x would be 0, y would be n minus 1. So then that means that we want to start at c minus 1 all the way to row. Yeah, right. And then now you don't have to do xy loop because y is just x. Well, x minus y is equal to d, right? So then you could add y on both sides minus d on both sides. So this is equal to y, right? We'll just do that math real quick. And then yeah. And then maybe now you do an array that you could sort. I mean, you could still do them in place, kind of. Doing this way is probably a little bit cleaner, but yeah. And then we just sort, and we have to do a quick sort, or not quick sort, sorry. We have to do a sort that is quick, but have to mind that if an if statement, which one is it? So x minus y, where y is going to be on the upper. So if d is less than 0, we want it to be sorted in this way, and then else, I mean, you want to sort it in reverse is equal to true, or reverse is equal to true. And of course, you could make this one line of you really cool. You were trying to be cool. You can do like reverse is equal to not, you know, or something like that. I don't know, right? But that's where you may make a mistake sometimes, as I often do. Anyway, and then you throw it back in, right? And that should be good. Grid of xy is equal to array of x, right? Because x is just from 0 to whatever. Is this to R? This is actually, I have to be a little bit careful here. I mean, we kind of wrote on top of what I did previously, so I forgot what it was. So x in this case would go, it's like c minus d or something like that, right? Something like that, maybe. All right. I mean, the way I'm figuring out, by the way, I'm just looking at this grid and just try to work out in my head. For example, if the diagonal, or if x is equal to, in this case, 3, x would go from d, right, d to r. I guess that's right, right? Because then do, right? Yeah, because or well, it goes from d to either r or no, it's not d. Sorry, because d is negative. I forgot. Because I'm trying. If you're wondering what I'm doing, I am just trying to actually do the math. Okay, so because for example, if I look at here, we have the 2, 0, where the 4 is. So that's diagonal, and x will start from 2, right? And that's the diagonal of 2 minus 0, which is 2. So we can start from d, right? And then if it's negative, then what happens? If it's negative, it starts at 0, and then it goes up to not r anymore, but only up to c minus d or something, right? So this has to be and this is like something like this. Maybe I'm off by 1 or off by a lot, right? But anyway, if that's right, then everything else should be right, and it is not. But we'll see how we're wrong. Oh, right, because now this is, no, this should still be right, I think, because I'm just thinking, I mean, or is as right as this for loop is what I mean, right? So, well, we didn't change the array, so that's not right. Oh, I think I was just lazy with this x. I think what I need to do is maybe someone like enumerate. Yeah, I'm okay. I would have expected to go out of bounds, honestly. So maybe that's not quite it. We could, right, we could print the array real quick, pre-sort, just to make sure that we are correct. Oh, it's not printing out anything, right? See, oh, why did I write it? Huh. I mean, it is. I see. I see. I mean, it's not c minus one. Diagonal is negative of this, is what I meant. I think I just got confused a little bit because I was saying -2, and then now we go out of bounds in a correct way. This is 0. This is now this is negative, so that's why this is a little bit awkward, right? I was expecting some sort of things here, but I think I got a little confused because D is. Oh wait, no. If D is negative. This is why we don't do it this way, to be clear. But I'm trying to challenge myself a little bit. But yeah, okay. So it's 0, 2. So 0, 2 is the diagonal, say. Then you want go or 0, 2. So -2. You want x to go from 0 to 0. So it should be right. Am I not? This is 3 minus. Oh, this 3 minus negative. I forgot that we did that. So yeah, so it's very awkward, maybe. But yeah. Okay, so it prints out this one, but then maybe the next one is not quite right because of this. Now it's adding. I don't know, right? But we can also just print out what this is. So we can see exactly why we're going out of bounds. Yeah, because then x goes from 0, 1. Okay, that's Gucci. Or it's from 0 to 1. Yeah. Why do I... where am I out of bouncing? Oh, on this I. Oh, we just didn't fix this, that's all. I was so focused on it. I thought it was on the next iteration. But clearly, you know. Yeah, okay. So, yeah, like a minor thing, right? I didn't actually even look at this because 3 is a crappy example. Maybe even this one's a crappy example. So I don't know. Maybe I'm a little bit overconfident, but I am going to YOLO submit because with sorting, everything is to the library, right? So if it was like, I guess my biggest one was only this one, whether I sort, like if I were to make a silly mistake, it would have been the diagonal right in the middle because maybe I got on the wrong sign just because of this or whatever. But because the other two is actually kind of useless, right? This is an empty thing, so it doesn't do anything, or like a one element doesn't change array. This is 2 elements, but you only change the diagonals, which I guess tests the main diagonal, which I was worried about. But yeah, but still, yeah. What's the complexity here, right? It is going to be, let's just say, so the number of diagonals is just 2 times the number of rows, right? And roughly speaking, and each of these sort will do also roughly speaking C log C. I mean, it's not quite that. Well, let's actually change it back to, instead of using R and C, which is a little bit confusing with this one. Maybe not, but let's change it to some number S, right? Which is elements on one side. So we said that we sort everything, just dump everything the way that we did. Then the easy lower bound is going to be S squared log, this. You take out the 2, and the reason is just because if you sort everything, you're fine. You're fine, right? And you can take out the square because of the log factor. But the way that we did it, are we faster? I don't think so. But yeah, because there are S diagonals, right? And each one takes s log s to sort. So it's also gonna be that. I mean, I think yeah. I mean, the better so it's gonna be the same. I mean, we sort everything the same, right? Right. We just sort every diagonal once, so there's no way for that to be different. So the different part comes from peak memory usage, I guess, is a little bit lower because instead of having s square number of elements in memory, you only at most have O of s memory, which for bigger s may matter, right? But for 10, obviously it doesn't matter, right? For s is equal to 10, it obviously doesn't matter, but yeah. Anyway, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.